morning, all of you. Today we discuss some very important examples of chemical changes. Already you know about what is mean by chemical change, what is mean by physical change. Okay, so what is the chemical change? So the change in total molecular composition is changed. Molecular composition is changed. If you take physical change, there is only solid to liquid, liquid to gas, so the physical states are only changed, but the formula of the compound means the chemical composition does not involve in change. But the chemical change, what happens, the total molecular composition different, means the formula of the compounds are different from reactant to products. Okay, so now we see some of best examples of and important examples of chemical change. So there is the first one. So burning of magnesium in air. So we'll write some bold letters. Burning of magnesium in air. Now we see what happens when magnesium is burned in air. Okay, so when magnesium ribbon, generally the magnesium is this, the length is just like in the form of ribbons. Okay, so it is treated as a magnesium ribbon. So it is just like this. Okay, say this is the magnesium ribbon. Okay, when magnesium ribbon is heated, nothing but burned in the presence of air. So air lo dinni burn cheste modante when it is burned in air with the help of a burner flame. So it reacts very quickly and forms a bright white color flame. Okay, so normal ga etla burn avudante if you see with direct our eyes we get a reflection on our eyes, means very bright. So very bright color ga white color flame form avutadi. So within fraction of minutes lo burning total ga burn అయిపోయి so finally it forms a black color ash. Okay, sorry, it's one white magnesium forms white color ash. Adhe manaki if you see the carbon compounds, they forms the black color ash, the magnesium forms a white color ash. Okay, means this magnesium, on heating the magnesium, it burns very brightly. Okay, so brightly forming white color flame. Okay, white color flame was very bright ga untadi, though finally it forms a white color ash. So what is the chemical reaction? Yes, is chemical reaction. When magnesium burned in air, it combines with oxygen and forms magnesium oxide. Okay, and form magnesium oxide. So now balance the equation: 2 oxygens, 2 magnesium. So the solid ribbon, so there is a solid, oxygen is gas. Next magnesium oxide. So magnesium oxide, that is a white color ash. The magnesium oxide is also solid and it releases again lot of heat. Means it is which type of reaction? It is an exothermic reaction because some heat is liberated due to this. So this reaction starts on burning, but after burning it is dazzling light. So brightly means here we can use very dazzling light and a very brightful. So dazzling light and come. Okay, so this is the burning of magnesium in air is a chemical change forming a new compound magnesium oxide and releasing some heat. Okay, now I'll give the sentence for this. take the points perfectly because it's very important. Okay. We'll see the next one. See, the next example is rusting of iron. Okay. Rusting of iron. So we know the iron. So iron when exposed to air, when exposed to moisture air, it is after some time, after not some time, after some days, after few days, the rusting is formed on the iron. Okay, means it is a very slow reaction and it is a chemical change. So what happened during the rusting of iron means, so at first iron reacts with oxygen of air. Okay, at first iron reacts with oxygen of air and forming iron oxide, that is called ferric oxide. Ferric oxide is formed. Okay. Again this ferric oxide combines with some water molecule. There is no fixed number of water molecules. That's why I given X. Means the ferric oxide molecules formed by iron combined with the available number of oxygens and forming hydrated Fe2O3. So this is called rust. Okay, the formula of rust is this one. Okay, but it is a chemical change, but it takes place very slow. The rusting of iron is a very slow reaction. It takes some days. Okay, just within hours, rusting of iron does not take place when it is exposed in air. When it is exposed in air, then only rusting takes place. For example, take iron sheet. So iron sheet, one iron sheet at the outside of our home. Next one iron, the same type of iron sheet at inside of our home. Okay, so which easily rusting takes place. So rusting of iron, which is present at the outside of the home, it takes place within few days compared to the iron sheet present in the home. The present in the home also it exposing air, but it is compared to the outside, it is very less. That's why the iron sheet the iron sheet placed at the outside of the home is undergoes rusting very easy compared to the inside home. Okay, means it happens due to the reaction of iron with the oxygen. So oxygen so react a ferric oxide form होता है. The ferric oxide combined with water. So where they get the water? So they get oxygen from air. This is also moisture of air. Okay. Okay, moisture of air. So this is the rusting. Means rusting is a purely chemical change, but it is a very slow reaction. So it is the matter for rusting of iron. So when iron is exposed to moisture air, so it become reddish brown powdery so మనకి రస్టింగ్ కింద ఆటోమేటిక్ ఏమవుతుంది, సో దాన్ని మనం జస్ట్ పట్టుకొని కొంచెం ఫోర్స్ అప్లై చేసినా ఈజీగా బ్రేక్ అవుతుంది. ఇట్స్ కలర్ is also changed. So its color is not exactly color, not in brown color, not in reddish. So it is a mixture of red and brown color. That's why we treated it as a reddish brown powdery mass. అంటే మొత్తం దాన్ని మనం ఫోర్స్ అప్లై చేసి ఇట్ బికమ్ పౌడర్ లాగా ఫామ్ అయిపోతుంది. సో that is called rust. So when iron exposed in air, it combines with oxygen at first. It combines with oxygen at first. So where it get the oxygen means from air, forming ferric oxide. The ferric oxide again combined with some molecules of water. So where they will get water? It is also from air. Okay, that's why we treated moist air. So some percent of moisture is present in any air, so forming hydrated ferric oxide. Actually, so this is treated as rust. Means if what is the formula of the rust means that is Fe2O3 dot XH2O is called rust formula. Next see one more best example. Next, burning of LPG. So burning of LPG. So you know about LPG, where we used that LPG. So LPG is a gas, okay, the cooking gas. The cylinder we used in our kitchen is having LPG gas, nothing but LPG. So that is treated as liquefied petroleum gas. But the many said that is the liquid petroleum gas. It is not the exactly one. LPG means liquefied petroleum gas. Okay, LPG means liquefied. Liquefied petroleum gas. So on burning of that gas only, the cooking process takes place. So what happened when LPG burned? So actually the liquid petroleum gas is contain butane gas. The gas present in that cylinder is butane, that is C4H10. The gas present in the LPG cylinders, is butane. Okay, when butane is we are burning in the air, nothing but in the oxygen, it forms carbon dioxide and water. Okay, so high temperature kabatti, so it is in the form of steam. CO2 already present in the gaseous state. Now just balance it. So here 4 carbons, by putting the 4 oxygens, 4, 8, 9. So again it become even number and odd number. So we need to change it. It becomes 8, 12, 13. So 13 is also not positive again. Let's do it 13. So again here also using 10 it is possible. So okay, it is so again it releases a large amount of energy. Okay, on heating butane, we are burning the butane gas, that LPG means so in the presence of air only we do the cooking in presence of air, it combines with in the presence of oxygen only the burning takes place and forming carbon dioxide and H2O. Means the using of LPG is also not 100% safe, not 100% environment free, because it is releasing CO2 gas. Okay, and just recently the many countries are also banned this using of LPG. Okay, so this is the perfect chemical change, because so this gas, so this butane react with oxygen forming CO2 and H2O. So this is totally a chemical change. Okay, see the matter for burning of LPG. So on burning LPG, it burns with a pale blue flame. So already we know what is the color of the flame coming from our gas stove. So include just a gas stove, what is the flame? Okay, so perfect just it is perfectly in a blue color flame lo untundi, normal red color kaadu. For example, so normal burning, normal by the burning of leaves, burning of some plants, okay, stems. So when paper burning, so just say it is in red color, but LPG burns with blue color flame. Okay, LPG burns with blue color flame and releases a colorless gas CO2, because so we don't observe the gases are released there. What gases are released? The CO2 gas and water vapors are released, but we can't observe them because they are colorless. Next, other important one, we said the liquefied petroleum gas, but here it is C4H10. In our cylinder, if you shake the cylinder, it appears like a liquid. Okay, we feel that is a liquid. Yes, the inside that is a liquid, but when it comes outside, from the cylinder, it is directly converted into gas, because the cylinder was in the cylinder the gas was placed at high pressure condition. Okay, then only it is present in the form of liquid. When it come outside, so outside means in the normal pressure, it becomes gaseous state. That's why we put gas here. Okay, this is the burning of LPG, which is perfectly a chemical change. Okay, next we see some more examples. Mixing of iron fillings. Okay, iron fillings means we are taking the small pieces of iron is treated as iron fillings with sulfur. So mixing of iron fillings with sulfur. So here it is very important. There is a two possibilities are present. The mixing of iron fillings with sulfur. Just mixing is a physical change. Okay, only mixing is a physical change. Only mixing of iron fillings means so iron pieces with sulfur is a physical change. But the important thing is, if you heat that mixture, so this example is very important, because there is a two possibilities are present. Just only mixing of iron fillings with sulfur is a physical change, but but on heating the mixture, it is a chemical change. On heating the mixture, it is a chemical change. So very important points. So what happens of this reaction means there is a formation of, so compulsory heating is necessary. Without heating, it is a physical change. That's why I given this example. So when iron, sulfur mixed and heated, there is a formation of a ferrous sulfide is formed. FeS. It's already balanced perfectly. Fe plus sulfur. So what are the physical states? So all are in solid states. Okay. So iron solid state. So all are in solid state. So this is it. What is the name of this compound? Ferrous sulfide. Okay, because Se is present in the form of -2. This is Se is sulfur is present in the form of -2, Fe plus 2. So that's why it is the ferrous sulfide. Okay, got it. Next we see one more example. So then again it is a very important example, that is a person eats a chocolate then digests it. Okay, I mean nothing but it is a digestion of food, but it is given the question like this. So a person eats a chocolate then digests it. Means we know the digestion of food. Digestion of chocolate means nothing but digestion of food. It is a example for chemical change. Okay, because the digestion takes place. Okay, when it is taken into our body, the food combines with many type of chemicals. Different enzymes are present. So the digestion of food not simply is a physical process, it is a chemical process involved in it. The many chemicals like enzymes, okay, present at different parts of our body, combines with the food, and digestion of food takes place releasing energy. Okay, means so simply we can say the digestion of food. So here given the chocolate, but simply we written as a digestion of food. Digestion of food is a chemical change. Is a chemical change. Why we treat as a chemical change means as the food taken by combines with many number of chemicals. We can't name any one chemical because there is a lot of chemicals are present. Lot of chemicals react with that food. So the food taken by us is combines with many chemicals of our body during the digestion. There is no particular reaction. We can't give the particular reaction because there are many chemicals are present. But finally, we can say digestion of food is a chemical change. Okay, next. So one more important example is there. So the next example, a frog breathes heavily. Okay, we know the breathing process here. So there is a breathing process is different and respiration is different. So breathing of a, just here given example, frog. So what breathing takes place? Okay, so the breathing of frog, what takes place means it inhales the oxygen. Okay, it inhales the oxygen and it releases out the carbon dioxide. Means there is no chemical reaction takes place. Okay, just it is given breathing process, not the total respiration. So respiration means there is some chemical changes are present, but in the question it is given the confusing that what is the breathing of frog and all. So breathing process, simply breathing of frog and it inhales oxygen, releasing the carbon dioxide. Simply we can take it as a physical process, but if it is asked the respiration process, that will be a chemical change. It means we can write directly that breathing process. In breathing process, frog inhales oxygen and releases carbon dioxide. So it is a physical change. But so it is a related kabatti I am writing another point. But the respiration, if it is given, but respiration is a chemical change. Okay, so these are the important examples of chemical changes and physical changes. So I think that now you are perfect how to differentiate the what is the chemical change and what is the physical change. Okay, so you need to practice it also, because the formation of the presentation of the words is also very important. Okay, so already I sent you to all of you a question paper. So is that completed or not? If you have any doubts, just ask me at the comments. Okay, ask me at the comment box. So I will ready to help you. Okay, but you need to complete it as soon as possible. So next day we see the chemical reaction. So actually there is no big difference between the chemical change and chemical reaction. So both are treated as a simultaneous words, but very small difference takes place in the definition. Okay, so read the examples perfectly. Yesterday we given the total list of chemical changes. You need to by heart, you need to remember all the examples. Okay, means in questions a process is given and it is asked that so is it a physical process or a chemical process. We need to identify that is a chemical process or physical process. Okay, some natural process so directly we are able to guess it, but some process are there we can't guess it. So remember that all list, okay, given yesterday. Okay.